Hello everybody, welcome to One Math Army. My name is Mohammad Taqi Hassan and I am your mathematics mentor in this channel. And today we are going to learn about geometric progression part 2. In this session, we are going to learn about the properties of geometric progression. First of all, I want to congratulate the previous session's homework answers who gave the correct answers, and the only one who gave it was Renuka Ravi, and the correct answer was option C. Now let's check how we did that now. This is the question. The sum of the first 100 terms of an arithmetic progression is -1, and if the sum of the even terms lying in the first 100 terms is 1, then which of the following statements is or are correct? Now, option A, common difference of the arithmetic progression is -3 by 50. Option B, first term of the arithmetic progression is 149 by 50. Option C, 100th term of the arithmetic progression is 74 by 25. Now let's see how I did that. Now first we know this is, let's take this as our AP here, A1, A2, A3 and so on up to A100. Now the first term here is A1 and the common difference is D. Now A2 is A plus D and A4 is A plus 3D. And A3 is A plus 2D. We all know this from the first session. Now sum of the first 100 terms is n by 2 into 2a plus n minus 1 into d. And just substitute the value of n as 100 and just substitute the value of n as 100 and you're going to get this equation. 50 into 2a plus 99d equals to -1. Now take that as our equation 1, and we need another equation to solve this because this contains two variables. One is the first term a, another is the common difference d. So for the other equation we're gonna get that from this line over here. The sum of the first 100 terms is 1. So most of you confused at this point how to take that. So in this case my even term is a2, a4 and a6, like that, and we know that a2 is a plus d and a4 is a plus 3d. Now here the first term is a plus d, first even term is a plus d, and the common difference of this only even terms is a plus 3d minus a plus d, which is 2d. Now again sum of the even terms 50, because if I have 100 terms, 100 consecutive terms, then 50 of them will be odd and 50 will be even. So the sum of the even terms in these 100 terms will be 50 by 2 into 2 into, and the value of a is a plus d, so 2 into a plus d plus n minus 1, the value of n is 50. 50 minus 1 into d, the value of d is 2d here, and I substituted that equals to 1 given in the question. Now simplify this and you're going to get another equation. SE, the sum of even terms, equals to 25 into 2a plus 100d equals to 1. Now take that as your second equation, and this over here is my second equation. This is our first equation. I'm just keeping them side by side to compare them. I'm going to simplify that from here. If I subtract the first equation from the second equation, or the second equation from the first equation, it's all the same. I'm going to get the value of d as 1 by 25 plus 1 by 50. So I'm just sending this 25 over here, which will become 1 by 25, and this 50 over here, which is 1 by 50 minus 1 by 50. Now here if I subtract these two, what I'm going to get is 2a plus 100d minus 2a plus 99d. 2a will get cancelled out, and 100 and d minus 99d is 1d. d equals to 1 by 25 and minus into minus, which is plus. That will be d equals to 1 by 25 plus 1 by 50. From there I get the value of d as 3 by 50. Now I'm going to substitute the value of d in equation 1 over here, this equation, and I'm going to get the value of a. And again we got the common difference as 3 by 50, but the first option states that it is minus 3 by 50, so it's wrong, it's not the correct one. And if I substitute that, I'm going to get the value of a as minus 149 by 50, which is also wrong. It is negative 149 by 50. The option states that is positive, so that is too wrong. Now T100, the 100th term is a plus 99d. We all know that. Substitute the values of a and d, you get 74 by 25, and that statement is stated by option C, which is true, so option C is correct. Now let's head on. Now in the previous chapter we have learnt about the general formula and the general way of expressing a geometric progression. In this session we are going to learn the properties of geometric progression. So we have completed arithmetic progression, we have completed 1/3 of geometric progression, and we are doing the second third right today. The first property of geometric progression is similar to the first property of the arithmetic progression, which is if a constant quantity is multiplied or divided by each term of a geometric progression, then the resulting sequence are also in GP with the same common ratio. So if I say I have a just write that down. So this is our GP over here. A AR square, AR cube, so this is this is my GP over here, and if I multiply this whole GP, that means I'm multiplying individually each term with a constant k. This will become AK, this will become AKR, this is AKR square, and this is AK, this is AK whole square, AK whole square, yeah. No, sorry, wait a second. No, this will be AK itself. This two. Now, in this geometric progression, the common difference again is R. AKR divided by AK is nothing but R. AKR square divided by AKR is also K. R, sorry. Now, I am not multiplying the previous term with K to get the next term. I am multiplying each term with K. That's why K does not have any power to it. It's just K. Now, similarly, if K is written as 1 by K, then it will become division, right? No. Second, the reciprocals of the terms of a GP form a GP. So A1, A2, A3 and so on, A4, AN are my GP, and then A1, 1 by A1, 1 by A2, 1 by A3 and so on, 1 by N are also in geometric progression. Now, if the each term of a geometric progression is raised to the same power, then the resulting sequence is also a geometric progression. So let's say I have this GP over here, AR square, AR cube, and so on, AR. Now if I raise each term in this geometric progression to say some kind of constant K, so this will become AK. And just keep that in brackets again. Okay, just a second. Oh no, just wait a second, guys. Okay, and similarly again like that I'm gonna get okay. So this is our geometric progression after raised to the power K. And if I divide a to the power of K, if I divide a to the power AR to the power of K by AK a to the power of K, I am going to get the common ratio as R to the power of K. Similarly, if I divide the third term to the second term, I'm going to get R to the power of K. So it will also be a geometric progression, but the common ratio will be r to the power of k. Now if I take 3 terms, say in a GP we are solving problems and you have to take 3 terms, then it is better to use this type over here: a by r, a, then ar, next a by r cube, a by r, ar, and ar cube. So this is when we use 4 terms. Now if a, b, and c are in GP, then b square is equal to the root of ac. Sorry, b equals to b equals to root of ac. This is not b square. This is b equals to root ac. I'm going to tell how I got that in the next session, which will be about geometric means, and you will understand how we get this thing. Now this one is similar to arithmetic progression. Let a1, a2, a3, and so on, a4 be in a geometric progression. Then the first term into the last term, and the second term from the beginning into the second term from the last, and so on, is all are equal. So the general form of that is here. This is the first term here, a1 m means the mth term into a1 n minus m plus 1. If I multiply those, I'm going to get the same thing. Let me just make it clear to understand. Okay, and the first term is a. Okay, now the mth term and the n minus m plus 1th term, if I multiply that, it's going to be same for every value of m. Now if the terms of a geometric progression are chosen at regular intervals, then the new sequence will also be a GPA. So if I have a1, a2, a3, a4, and so on, an, and I pick them at regular intervals, say I skip a1 and I pick a2, then I skip a3 and then I pick a4, and so on, I'm going to get a GP like this: a2, a4, a6, a8, and so on. And those that sequence is also in geometry progression. Now this is an important point. If a1, a2, a3, and so on, an are non-zero, non-negative terms of a geometric progression, then log of a1, log of a2, log of a3, and so on, log of an forms an arithmetic progression, and vice versa. So if log a1, log a2, log a3 form a arithmetic progression, then a1, a2, a3 are in geometric progression, and the opposite of that. Now let's look into a question here. It's a very easy one. I'm going to give you 15 seconds to solve this question, and your time starts now. This was a very easy question. Here's the solution. First, I'm given that a, b, c are in arithmetic progression, so the common difference will be same. So the third term minus the second term should be equal to the second term minus the first term. So here our third term is c minus the second term, c minus b equals to b minus a. So this is our condition. If I simplify that, I'm just going to get 2b equals to a plus c. That's what we get if I expand that. Now this is what we know from the first half of the line over here, and from the second half we can find out that b minus a, c minus b, and a are in geometric progression, so they should have a common ratio, right? So the common ratio of the second to the third term should be equal to the first to the second term, right? So the third term divided by the second term should be equal to the second term divided by the first term. Now from that, so take that as equation 2. I didn't mention that here. So first of all, this is the main equation over here: c minus b equals to b minus a. So take that as I, equation I. Now from the first equation, or equation I, we get that c minus b equals to b minus a. So here I am going to substitute the value of c minus b as b minus a. So this is going to be a b minus a, and this is going to be a b minus a. Then these denominators will get cancelled out. Then a will be equal to c minus b, and we know that c minus b equals to b minus a. So a equals to b minus a. Again, if I take that a to the left hand side, I'm going to get this equation over here. This is what I have, and if I take this to the right hand side, I'm going to get b equals to 2a. So b is twice the times of 2a. No, the value of a is a, as we know, and the value of b is 2a. So up to here we know. Now I'm going to substitute the value of 1. So I took that as equation 1 in I. If I substitute the value of 2a here, c minus 2a equals to 2a minus a. 2a minus a is nothing. 2a minus a is a, right? And c minus 2a equals to a. Then obviously c will be 3a. So that's what we got here. And the question is a is to b is to c. A is to b is to c is nothing but a is to 2a is to 3a, which is 1 is to 2 is to 3. Now let's go to the homework question over here. This is the homework question for you. A square is drawn by joining the midpoints of sides of a given square. Thus, a third square is drawn inside the second square in the same way, and this process continues indefinitely. So let me give you a hint. This is a infinite geometric progression. If a side of the first square is 16 centimeters, then the sum of the areas of all the squares is. This may be tricky, and you can pause the video if you want more time, and you don't have options for this. It's a integer type. Until then, bye bye. I'll meet you in the next session.